All right, welcome back to another episode of Math with Mr. Young. Today we're going to work with 6.3 solving equations using multiplication or division. Our standard is 6th grade evaluating expressions A, and our objective is that we're going to be able to write and solve equations using multiplication or division. Our mathematical literacy, we have inverse operation and solution. All right, for 6.3 solving equations using multiplication or division, our success criteria is that we're going to be able to apply the multiplication and division properties of equality to generate equivalent equations. We're also going to solve equations using multiplication or division, and also create equations involving multiplication or division to solve real-life problems. Now, very importantly, we do have mathematical literacy here. We have the multiplication property of equality and the multiplicative inverse property. Okay, so this is what we do when we multiply and solve equations with multiplication. Now, the multiplication property of equality is when you multiply each side of the equation by the same non-zero number. When we do that, the two sides remain equal. So what that means, non-zero. So if I have a non-zero number, I'm talking about a number that is not zero. Okay. So when in multiplication, when we multiply a factor times another factor that equals a product, okay, when we multiply, so if I have a factor 1 times a factor 1, that's going to be the product 1. So again, that would be like the identity property of multiplication. But if I have a 0 as a factor times a 1, then that would be 0. So when I say non-zero number, I'm talking about numbers. It could be counting numbers, rational numbers, irrational numbers. As long as they're not 0, it's basically what we're saying here. It has to be a non-zero number that we put on both sides of the equation to make the equation true. So for the numerical expression here, or the numerical equation, we have numbers in algebra. So we're going to use the multiplication property of equality, and we're going to multiply each side of an equation by the same non-zero number. So in this case, what I want to do over here, I want to get, to make this equation true, I'm going to multiply this by 4 on each side. Okay. These guys kind of cancel out. So what's left behind is 8. And 2 times 4 is 8, so that checks. Okay. So 8 is equivalent to 8, so that makes that true. Same thing algebraically. If I were to have x over 4 equals 2, and if I were to multiply each side by 4, then x would equal 8 again. Okay, so there you go, and that makes that true. And again, 4 is a non-zero number. Now when we look at the multiplicative property of multiplication, this is where the product of a non-zero number n and its reciprocal 1 over n is 1. So what that means is, earlier we learned about reciprocating. So we have, like, let's say 1 over 2, and if we reciprocate that, it's going to be 2 over 1. So in this case here, these are products of non-zero numbers. So if we were to multiply them, so 1 times 2 is 2, 2 times 2 is 2, then 2 divided by 2 is 1. So that's what we're saying right here. The product of a non-zero number and its reciprocal is 1. Okay, so in this case we have numbers here. What we're going to do is we're going to use 5. Now to make 5 into a fraction, we put a 1 underneath of it, and then we're going to reciprocate. 5 over 1 becomes 1 over 5. 5 times 1 is 5. 1 times 5 is 5. 5 divided by 5 is 1. Okay, so again, the product of this non-zero number, 5, and its reciprocal, 1 over 5, is going to equal 1. Algebraically, we're going to have, let's say n, okay, whatever n is. And now I want to reciprocate that. So n times 1 over n, okay, 1 times n is n, 1 times n is n over n still going to be 1. Okay, so whatever the value of n is, it could be any value out there. we're still going to get the product 1. And that's the multiplicative inverse property, okay, and the multiplication property of equality. So we're going to use those two to help us out, and we'll apply them to the next examples. All right, so for these examples, we're going to solve equations using multiplication, keeping in mind the multiplication property of equality and also the multiplicative inverse property. Okay, so we have two problems here, A and B, and we're going to solve. So the first one we have W divided by 4 equals 12. Now again, you always want to isolate the variable. Isolate means that we want to get that variable by itself. So we do that by multiplying the inverse operation. We're dividing here, so the opposite of division is multiplication. And we multiply on both sides of the equation. Again, the equation is that equal sign. So both sides of the equal sign, again, think of that teeter-totter and keeping both sides balanced. Now, this cancels out, and W is by itself, okay? Now, 12 times 4 times 2 is going to be 8. 4 times 1 is going to be 4. So we're saying that W equals 48, okay? So now what we got to do is we have to check. So we're going to check to see if this is true. So let's rewrite the equation. W divided by 4 equals 12. And if we insert 48 for W, and we see that 4 can go into 8 twice, 4 can go into 4 once, and 12 is equivalent to 12, so that checks. So that is true, and our conjecture is right that W equals 48. Okay, let's do that again, but this time here we use the multiplication property of equality, keeping both sides, or doing the same thing on both sides of the equation. Here we're going to use the multiplicative inverse property. So again, that's where we reciprocate, and again we apply that to both sides of the equation to isolate for the variable. So 2 over 7, again that's going to be, we're going to reciprocate that. So this becomes 7 over 2, and if we were to multiply that, 7 times 2 is 14, okay, and 2 times 7 is 14, but 14 can go into 14 once. So this is basically 1. Now that basically cancels out, and this variable x is by itself. Okay, now the same thing here. We're going to multiply 6 times 7 over 2, and again we make that into a the whole number 6 into a fraction by putting a 1 underneath of it. And what we're going to do next is we're going to go ahead and multiply. And 6 times 7, that equals 42. And then 1 times 2 equals 2. So again, you can reduce that, okay, if you want to, or you could just divide. But we're going to divide it by 2. And half of 48 is going to be 21. 2 can go into 2 once, and 21 over 1 is just going to be the whole number 21. So we're saying that x equals 21. That's our conjecture. Now let's check it. So if we substitute and rewrite the first equation, the original equation, 2 over 7x equals 6, let's substitute 21 for x now. 2 over 7 times 21. It should equal 6. Okay, we're going to make that whole number into a fraction by putting a 1 underneath of it. And 21 times 2 is going to be 42. And 7 times 1, let me move this up, 7 times 1 is going to be 7. Now 42 divided by 7, that's going to be 6. And 6 is equivalent to 6, so that checks. So that is true that x equals 21. All right, there you go. We're also going to be working with the division property of equality here. So it's very similar to the multiplication property of equality. Okay, so we're going to just know that when you divide on each side of an equation, we're going to divide by the same non-zero number. The two sides remain equal. Okay, So with this being said, we have numbers like a numerical expression or a numerical equation, and then we have an algebraic expression or an algebraic equation here. But because we have equal signs here, these are both equations. So a numerical equation and an algebraic equation. So we're going to solve these two. Now again, we're dividing with the division property of equality. So again, we want to make sure that we basically divide by 4 on both sides. 4 divided by 4 is going to be 1. 8 is by itself. And 32 divided by 4, that will be 8. And 8 is equivalent to 8. So there you go. That checks. On the other side, we have 4x equals 32. So again, it's basically the same equation. It's just that we take out one value. So in order to solve this, again, we want to isolate the variable and get that by itself. We do that by, if we're multiplying, if you have a coefficient 4 and a variable, you multiply. So the opposite of multiplication, the inverse operation of multiplication, is division. So we're dividing by 4 on both sides. 4 divided by 4 is 1. X is by itself. And again, 32 divided by 4 is 8. So we're saying that x equals 8. Now let's check this. So if we insert and substitute 8 for x and we rewrite the equation, 8 times 4 does equal 32. And 32 is equivalent to 32, and that checks. Now what we're going to do is we're going to go ahead and solve these two problems. So we're going to solve these equations using division. So we have two problems we're going to solve. 65 equals 5b. So we don't know what b is, but we're going to find out. So you have a coefficient 5 and a variable b. Now we want to isolate the variable b, get that by itself. We do that by dividing on both sides. We divide 5 on both sides of the equation. 5 divided by 5 is 1, so these cancel out. B is by itself, the variable is by itself. And 65 divided by 5, that should be 13. Okay, so we're saying that 13 equals B. Now let's check this. So we rewrite the equation, but this time we substitute 13 for B. Okay, now 13 times 5, so basically 5 times 3 is going to be 15. 5 times 1 is 5, plus 1 is 6. So 65 is equivalent to 65, and that checks. All right. Same thing for this one. They're both algebraic equations. So we have p times 3 equals 18. So again, this is basically like a coefficient and a variable again, but if we're multiplying, the opposite, the inverse operation of multiplication is division. So we divide by 3 on both sides to get the variable p by itself. And 18 divided by 3, that is going to be 6. Okay, so we're saying that p equals 6. And what we're going to have to do is check. We rewrite the equation, p times 3 equals 18, and then insert and substitute 6 for p. So 6 times 3, and 6 times 3 does equal 18, and 18 is equivalent to 18, so that checks, and that makes that equation true. So p equals 6 is a solution of the equation. For the other side, 13 equals b is a solution for that equation. All right, and lastly, we're going to work on modeling real life here. So let's read the paragraph and see what this is all about. So the area of a rectangular LED sky screen in Beijing, China is 7,500 square meters. The width of the sky screen is 30 meters long. What is the length of the sky screen? So in order to do this problem, first of all, let's understand that there's some geometry here. So we're working with the area of a rectangle, and the formula for the area of a rectangle is the area equals how long it is times how wide the structure is. Okay, so that's how we find the area of the rectangle. So I don't know if you guys have ever been down Fremont in Las Vegas, but down Fremont Street there is this like kind of looks like an LED screen up top. It plays like all these different images. So that's kind of like what we're talking about here, a sky screen. Okay. So as we move on, so we want to know, we know the width of this sky screen, we know the area of it, but we want to know the length. So let me draw that out. Let me draw a diagram. So that sky screen, the LED sky screen, it is 30 meters wide. That's the width. We know that the whole thing is 7,500 square meters, and that's the area. And the area is like all that space in the inside, okay, of the box. But what we don't know is the length. We don't know the length, okay? So that will look like this. So we know that the area equals 7,500 meters squared. We don't know the length, but we do know that it is 30 meters wide. So notice that I've made 30 a coefficient and L is the variable. So again, using what we learned before, looks like we're going to be dividing solving this equation using division. So we want to get that variable by itself and isolate it. So we divide by 30 on both sides of the equation. 30 divided by 30 is 1. The variable L for the length is by itself. So I can kind of cross that out. And then we can do this where we have 750 divided by 3. That will be 250. Okay. And we're saying that 250 equals the length. So we're saying that the length is 250 meters long. But let's check this, okay? So let's check this by inserting the 250 for L. So the area equals length times the width. This area is 7,500 meters long, or meters squared, I mean. And then 30 times 250, because that's the length for the sky screen. So if you think about this, if you can knock off these zeros and just do like 3 times 25, 3 times 25 is 75, okay? But then just like add those zeros back on, and 7,500 is equivalent to 7,500, and it checks. So that is true that the sky screen is 250 meters long. All right, so that's basically it. So if your teacher is Mr. Preston or Mrs. Keelis or myself for your math teachers, make sure you guys get your assignments in and catch up on your missing assignments and knock it out. I mean, there's only 10 questions on every assignment. These videos are there for you guys to view and watch, and you know, change things around. You guys are in charge of your grade, and if you don't like it, change it. Start turning those assignments in, okay? So that's all we're doing today for 6.3, solving equations using multiplication or division. By now, you should be able to apply the multiplication and division properties of equality to generate equivalent equations. You should also be able to solve equations using multiplication or division, and also be able to create equations involving multiplication or division to solve real-life problems. All right, we'll see you guys later.